Hello, and welcome to our first video on linear relationships, finding slope, and our focus today is going to be on graphs. You can see our focus standard up here, and our essential question is, what is the slope of a line and how do we calculate it on a graph? Please take a moment, pausing the video if you need to copy down the topic, the essential question, and the date in your header, set up your question column and your note column, and resume the video when you're ready to begin. Alright, as usual, we are going to dive in by starting to talk a little bit about vocabulary. So as you saw from our title, we are now in a unit called linear relationships, and linear relationships really means that we're describing a relationship between an input variable, the variable we use is x, but some sort of input, and we're comparing that to an output represented by the y variable that has a constant rate of change. That constant rate of change is what we refer to as slope, and it forms a straight line when graphed. So there's our basic definition. So we're looking at linear relationships, an x and a y variable that when we graph them form a straight line. That's why they're called linear, and it's a relationship because we're comparing two quantities. Alright, the next vocab word I want to focus on is slope. So slope, as you heard me describe up here, is a rate of change. So a rate is how fast something is happening, and we calculate that by comparing the vertical change, which is actually the y change, to the horizontal change, which is the x, and it's most often written in a ratio. And a reminder that ratio is the technical term for a fraction, so we write it as in fraction form most often, but there are other ways to write it as well. Please make sure you have these vocab words copied down into your notes, and let's take a look at some examples of lines on graphs and look at how we're going to calculate the slope or the rate of change. So there are four types of slope when we look at lines on graphs. We have a positive slope, a negative slope, a no slope, and an undefined slope. And I know that those graphs are hard to read. I'm going to zoom in for a minute, but I just wanted to let you know the format. So for this section of notes, you are going to want to set up 4 graphs. So you can see I have Desmos up here. I would suggest setting up your 4 graphs now and ensure that you have your y-axis running vertically. You want to go at least from 7 to -5. Notice that we're counting by ones here. We got our origin here. And then set up your x-axis running horizontally, going at least to -8, but it might be helpful to go as far left as -9, and then stretching all the way to the right in the positive direction to 8. So again, you're going to want 4 of these graphs. We're going to do 1 for each type of slope, and I'll give you some time right now to set that up. And then resume the video when you're ready to begin looking at the graphs and analyzing the slope. So the way we know we're looking at a positive slope is that the line starts low on the left-hand side of the graph and then rises. So here's my graph. I have my y-axis here, my x-axis here, and we can see this green line. So it starts low towards the left-hand corner. Anywhere down in here, it's going to start low, a positive slope, and it's going to increase, as if we were having to climb uphill. That's how you'll know right away if a line has a positive slope. And then this is the formula that we're going to be using for now to describe slope. So slope, that's what we're talking about, is the rate of change. How steep is it? And we use the variable m to describe slope. It's most commonly described as rise over run. Here's that ratio that I was talking about, the fraction form. To be more precise and add some more mathematical language and symbols to it, this triangle means change. So the rise is the change in y, right, that vertical change, over, in the denominator, the change of x. That's the run, that's the horizontal change. And we put values here. So we'll be filling that in. Okay, so for our first graph, we are going to put this line, and you might be wondering how exactly to make sure that that's precise. So anytime that I'm looking at a line on a graph, I look for these lattice points. Lattice points are places where the grid lines on the graph intersect and the graph of the line goes right through it. So here's one at -6, 1, so you'll want to point there. There's another lattice point at -3, 3, so you'll want to put a point there, and a point at 0, 5. If your graph goes this far, it also looks like there's another one here at 3, 7. So we look at our graph and we find all the lattice points where our line goes right through it. So what you're going to want to do though is graph the point -6, 1, -3, 3, 0, 5, and if your graph can fit it, 3, 7, and then you're going to want to use a straight edge and graph your line all the way through that. So once we have our line and we've marked the lattice points, when we're finding slope, we're looking for the change in y over the change in x. So to find the change in y, which is our rise, we start at one of the points that's on the lower left-hand side. So I'm going to start with this point, -6, 1, and I'm going to count how much it goes up to the next point so that it's on level with that next point. And so I'm going to start here. Looks like it goes 1, 2, so it goes up 2. So this would be a +2. And then for the run, the change in x, right, that's parallel to the x-axis, I notice that it goes 1, 2, 3, 3 points over. So we could check and see, does that hold true for between the next 2 points, between -3, 3 and 0, 5. So let's test that out as well. It has to be in order to make it a straight line. So I see from -3, 3, that point, to the point 0, 5, it goes up 1, 2. So again, I see a change in y of having a +2. And then the run, the change in x, the horizontal change between these 2 points is 1, 2, 3. So that is the same as what I have here. So this slope, this is the constant rate of change, how steep this line is all the way up between each of the points. So we would say that this line has a positive slope of 2/3, and our slope fraction is in simplest form, so we don't need to do anything else with it. Now let's take a look at our second example, what it looks like to have a negative slope. Anytime you notice that a line starts high on the left-hand side, like this, up in this corner, and then it decreases or goes down, like a slide, like something just go whoop and slide down, then you have a negative slope. Alright, but we want to be even more precise, so again, the first thing we're going to do is look for those lattice points. So points of intersection, so I see a point here at -8, 5. So we'll mark that point. I see a point here at -4, 2. So we'll mark that point as precisely as we can. You might be more precise on pencil and paper than I am with a mouse. And I also see 0, -1. And if your graph allows for it, I see another one at 4, -4. So you're going to plot those 4 points, and you're going to use a straight edge and draw your line, your negative slope line, through those points. All the way, edge to edge on your graph. We always extend lines all the way through. Now notice the thing that's different about a negative slope is it doesn't rise, it drops, right? Because the y values are decreasing. So you'll still sometimes hear it as a rise, but that change in y is dropping. And we're just looking between each of the points, how much is it dropping. So starting here with our point that's at -8, 5, we're going to count that. 1, 2, 3. So it has a change in y that is a -3 because it's dropping 3 grid lines between each point. And now we find the change in x. What is the horizontal change? And again, that is a negative 3 because it's dropping, but you can also think you had to count down towards the negatives 3, so that also is why it makes it a negative 3. All right, let's find that change in x. The run goes 1, 2, 3, 4. So our change in x would be 4. So the slope of this line, this negative line that drops and decreases, it has a negative 3 over 4. And if we check it on the between the next points, again we can see it drops 1, 2, 3, and then it runs 4, 1, 2, 3, 4. Again, a slope means it's a constant rate of change on a linear relationship, so in order for it to make that straight line, this pattern has to continue. We always want to make sure that our slope is, when we're writing it as a fraction, is in simplest form, and negative 3/4 is in simplest form, so we have just found that the slope of this line is negative 3/4. That describes how steep it is. Let's get ready for our next example. So for our next example, we're talking about lines that have no slope, and anytime we have no slope, it's a flat horizontal line. What you want to make sure you draw on your third blank graph is this horizontal line that goes right through 3 on the y-axis and extends all the way through your graph from the left side to the right side. There's lots of places that we could put points. I'm just going to mark a few, but we could put a point here at negative 4, 3. We could put a point here at negative 3, 3. We could put a point at negative 2, 1, right? Notice this, I could have started. I can even space them out a little bit more, it doesn't really matter. There's also one here at 2, 3. We've been counting how much does it rise or drop between each point to describe the change in y. Well, do you notice it rising or dropping at all? No, it stays flat. So our change in y is 0. It doesn't go up and over, it doesn't go down and over, it just goes horizontally to the right, it doesn't go up or down, so the change in y is 0. For change in x, it's just going over 1, right, and then we get to the next point. So it had a change in y of 0 and a change in x of 1, and then it goes over 1 again. So I'm just going to write that my change in x is 1 in the denominator. Now you've heard me say that the slope needs to be in simplest form. If you take 0 and you divide it by anything, in this case 1, what are you going to get? If you said 0, I absolutely agree with you. So the slope of any horizontal line, doesn't matter where it is on the graph, is 0 because it doesn't rise and it doesn't drop. It just stays flat. Alright, let's take a look at our last example. For our fourth and final example, we're going to talk about undefined slopes. An undefined slope is any vertical line. Here going right through the x-axis where x is negative 2, it's just going all the way up and all the way down. So on your fourth blank graph, please draw in this line. Again, we look for lattice points, and again, there's lots of places here where it crosses through intersection points, so I'll just mark a few of them here. I'll start with negative 2, 4, we'll go negative 2, 3, and negative 2, 2. Again, this will work for any of the points, but these are the 3 that I'm going to use. As always, we're finding our slope here. This time, our change in y, if we start, I always like to think about starting with the lowest point. So if I notice, it is increasing, vertical increase. It does have a vertical increase of 1, and that happens again to the next point. So our change in y for this vertical line is going to be 1. But this time we notice it doesn't go to left or right. Usually it goes to the right. That's kind of what helps it slant. But this is a vertical line, so it doesn't go left or right. So for the change in x, that's actually 0. It's not changing. It's not going left or right. It's just stacked right on top of each other. So for the change in x, I'm going to put 0. And that's true all the way up. So again, we have to make sure this is in simplest form. And what do we get if we take 1 or really any number, and we divide by 0, what are we going to get? This can be a little bit tricky for some students. If you said 0, I do not agree. So if you thought it was going to be 0, anything divided by 0, try that again. Actually get out a calculator, either on your device or your phone or somewhere, and do 1 divided by 0. If you divide anything by 0, you're going to get an error message, or what we refer to mathematically as being an undefined value. There's no way to divide by 0. So any vertical line, anywhere on the graph, any vertical line is going to be described as having a slope that is undefined. This is the end of our video. Please take a moment, make sure that your notes are complete. You might want to write your summary down here, which is answering our essential question in your own words. What is the slope of a line and how do we calculate it on a graph? I can't wait to look at this more with you in class.